Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which helps us in printing notes that don't have sibling. First, let us take an example. A sibling is a node that has same parent. In a binary tree, there can be at most one sibling. In this example, nodes 4, 5 and 6 are nodes that don't have siblings. Now, let us see the algorithm which will assist us in printing the nodes that don't have siblings. Let us also have a sample tree to test our algorithm. We pass the root node which is 1 to function print singles. So, root will point to 1. We check if root is null. Since it is not, we check if it is an internal node. As 1 has both left and right child, we recursively call the left and right subtrees using a call stack. So, root will point to 2. Again, we check if root is null. Since it is not, we check if root has both left and right child as not null. Since it is not, we move on to the first else if condition and print the right child of root. So, 4, which is the right child of 2, will be printed. Again, we pass the right child of node 2. So, root points to 4. Since neither of the condition is satisfied, we finish execution for node 4. Also, execution for node 2 is finished. We resume execution for root 1. So now we call for the right child of 1. So root points to 3. Since root is not null and 3 is not a full node, we check if left child or right child of node is null. As the right child of 3 is null, the second else if condition gets satisfied and we print roots left. So 5, which is the left child of node 3, is printed. Next, we pass the left child of node 3, which is 5, and finish execution for node 3. We check if 5 is a full node. As it is not, the second else if condition gets satisfied and we print roots left. So 6 is printed. We pass the left child of 5, which is 6. So root will point to 6. Execution for node 1 and node 6 is finished. We have the final output. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.